Okay, question number 1. We need to differentiate this expression here, and we can begin term by term. That gives us 10x minus x to the minus 2 minus 8x to the minus 3. The linear term becomes minus 3 and the constant term becomes 0. Okay, question number 2. We need to differentiate this, and we can begin immediately, term by term. So dy dx equals, that's minus 14 x to the minus 8. That becomes plus 6x to the minus 3. Then half x cubed becomes 3 over 2x to the 2. And the last term becomes 2 root 5x. Okay, so for question number 3, we need to first put it in negative indice notation. So y equals 2x to the minus 3 plus 5x to the minus 2 plus 4x squared minus x to the minus 7. And now we can differentiate. So y dash equals minus 6x to the minus 4 minus 10x to the minus 3 plus 8x plus 7x to the minus 8. Okay, for question number 4, we need to find f dash of x, and we begin by putting it in indice notation. So fx is 1/3 x to the minus 2 minus 1/4 x to the minus 1 plus 7 over 2 x to the minus 5. And now we can differentiate. So f dash of x is minus 2 over 3 x to the minus 3 plus 1/4 x to the minus 2 minus 35 over 2 x to the minus 6. Okay, question number 5. We begin by first expanding the brackets. So y equals, that's 8x to the minus 2. And then we have plus 6x to the minus 1. And then that becomes a 10 because the indices cancel. So that's a positive 10. And now we can differentiate. Dy by dx equals minus 16x to the minus 3 minus 6x to the minus 2, and the 10 disappears. Okay, question number 6. We begin by splitting up the fraction. So 4x over x to the 9, 3x squared over x to the 9, minus 6x cubed over x to the 9, plus 2 over x to the 9. And now we can simplify each term. 4x to the minus 8 plus 3x to the minus 7. minus 6x to the minus 6 plus 2x to the minus 9. And now we can differentiate each term. So you get minus 32x to the minus 9. There's a minus 7 there, so that's minus 21x to the minus 8 plus 36x to the minus 7 minus 18x to the minus 10. Okay, question number 7. We're given a function h of x. It's a double bracket, and we need to differentiate it. So the first thing we do is expand the brackets. So h of x, so you get 2x cubed plus 3x squared plus 2x to the minus 2, and then plus 3x to the minus 3. Okay, and there's no like terms, so we can begin differentiation. So h dash of x equals 6x squared plus 6x minus 4x to the minus 3 minus 9x to the minus 4. Okay, question number 8. And here we begin by expanding the brackets. We have a choice of putting it into negative indices and then expanding, or expanding straight away. Both should work. I'm going to just expand it straight away. So here we get 2 over x cubed. This is minus 1 over x. And here the x and x cancel, so we're just left with a 6. And we have a minus 3x squared. Okay, the next step is that we want to put these up. So that becomes 2x to the minus 3 minus x to the minus 1, copy the rest. And now we can differentiate, so we get y dash equals, that's minus 6x to the minus 4 plus x to the minus 2. The 6 cancels, becomes 0, and we get minus 6x for the last term. And because it was given as fractions, I'm just going to convert it in the following. Although it's optional, yeah, both answers are correct. Okay, question number 9. We begin by expanding and simplifying the brackets. So g of x equals 6x squared. Then you've got minus 14x plus 3x is minus 11x. And then you have minus 7. And that's all over x to the 10. And I'm just going to do the simplification straight away. So 6x squared over x to the 10 is 6x to the minus 8. And that over that is 11x to the minus 9. And minus 7 over x to the 10 is minus 7x to the minus 10. So if there's a 1 there, we just minus 10 off each of the indices, and that was x to the 0 becomes that. And now we can differentiate. So you get minus 48 x to the minus 9 plus 99 x to the minus 10 plus 7x to the minus 11. Okay, there's a little correction. It's not 7x to the minus 11. When that 10 comes down, it's positive 70x to the minus 11. Okay, question number 10. We need to differentiate this fraction. So we begin by expanding and simplifying. So we have y equals, so we expand the triple brackets. I'll write it out. That's all over 2x to the 4. So I'll expand the second two brackets first. So you get x to the 4 plus 6x squared plus 9. That's all over 2x to the 4. And we now need to expand the top. So x squared will multiply these 3 to give you x to the 6 plus 6x to the 4 plus 9x squared. Now the 3 multiplies these 3 terms to give you 3x to the 4 plus 18x squared plus 27 all over 2x to the 4. Now we collect like terms. X to the 6, we have 9 of them. The x squared terms, 9 and 18, so we have 27 x squared, and the plus 27 is on its own. That's all over 2x to the 4. And now we can finally split it up. So x to the 6 over 2x to the 4 becomes half x squared. This becomes 9 over 2. Here we get 2 over 27, 27 over 2, x to the minus 2, and 27 over 2x to the 4 is 27 over 2x to the minus 4. Okay, so now that we've put it in this form, we can finally now differentiate it. So we get y dash equals x, the 9 over 2 disappears, the minus 2 comes down, it cancels with that 2, so we get minus 27x to the minus 3, and the minus 4 comes down, we'll cancel with the 2 a little bit, you're left with a 2 left over, so you times 27 by 2 is minus 54 x to the minus 5. Of course you can just use a calculator as well. 27 over 2 times minus 4 should be this.